Okay, so I believe that we are probably live. All right, so a very warm good evening to everyone. Apologies for the slight delay that we are having just because of some technical issues. I can see that many of you are quite excited for the session, but you all have been asking that when we will actually begin. So, well, no worries. So, we are here once again back on our Spacetopia with a very exciting and fun session on a STEM challenge, which is for Sticky Lunar Dust Test. Now, STEM is something that I'm sure that many of you are already aware of. This is not the stem of the tree. Instead, I'm sure that people, especially who are aware of, who had subscribed to our channel and who are already aware that we are having the live right now, you might be aware that STEM is actually from our own company, STEM and Space, which stands for Science, Technology, Engineering, and Mathematics. So, including basically the entire math and science, we have this domain of STEM, and based on this STEM, we are going to perform a challenge on lunar dust. You can see that term on your screens, right? So something which is related to the dust on the moon, right? Because lunar is the word which we use for moon. So before we proceed towards the session, let me just quickly, what I will do is that I will show you a glimpse of the live sessions which we are actually, which is coming up very soon in this month of November. Oh, in this month of November, we have very exciting sessions, which we are starting with the STEM challenge today. Followed by this, we'll have a very exciting session on a very strange and oblivious object that we have got in our solar system this year. That is the comet 3I Atlas. We are having so many, theories about it, whether it's an alien spaceship. So we'll see about that in next week. Following that, we'll have a very exciting session on the Curiosity rover. For people who are not aware, it is one of the flagship rovers which we have sent to any planet outside the Earth. And following these three sessions, we'll finally have a mega quiz for all of you in the last week of this month, where we will include questions from these three sessions. So to participate in this mega quiz, make sure that you go to the spacetopia.in website, as you can see over here. And when you go over there, if you're already a member, you know what to do. But if you're not, you can register yourself. And after registration, you will land on the home page. And once you scroll down, you can find this quiz it up, which you can click. And once you click it, you will find that you will go to its page and you will be able to attend that. It's 20 days away, so it shows that it will come live. And at that time, you can participate to win very cool certificates and rewards for yourself. But to make sure that you are able to win those rewards, to increase your chances of winning, just make sure that you are attending all these three sessions, because most of those questions will actually be related to the things which we learn and discuss in these three sessions. So, well, with that cleared up, let's go back to today's topic, that is STEM challenge sticky lunar dust test. So I told you that this is something which is related to the moon dust itself, right? Now, let me just quickly show you a video of astronauts who are doing some different kind of activities on the moon's surface. So you can see that we have astronauts who are just jumping around on the surface of the moon, and they are even, performing certain other activities. They are trying to collect, and in fact, most importantly, they are actually trying to walk on the surface of the moon. And many of you are might be already aware that they are not able to walk properly because of something which is not present on the moon, but it is present on Earth and other planets as well. So do let me know in the chat that what is the reason why these astronauts are not able to walk properly on the moon. Well, before me in the meantime, if you notice closely in the video, you can see different features on the moon's surface. You can see certain, you can see certain rocks which are present. You can see certain hill and mountainous regions in the back side of the video. And if you notice closely, you can even see the surface. That means there is some kind of soil which is actually behaving pretty differently compared to the soil which we actually have on our Earth, right? And there are also certain depressions in some portions of the video that you can see, some huge depression-like structures. So for those of you who are not aware, we have several different types of features on the moon itself. So the depressions are actually called craters, which many of you have already heard about. The rocks and the mountains together actually form the surface, which is called terrain. And then you also have another feature which is related to the moon's surface itself. Okay. So let me know in the chat that which other feature is one I am talking about. And finally, the fourth feature, which I just talked about, is the moon dust itself. That moon dust is nothing but there is a very special term given to that moon dust, and that is called regolith. So, regolith is a very specific kind of term that is given to the dust on the moon as well as on the Mars and other planets. And it has been given this special term because of its own characteristic nature. This moon dust is very fine and smooth. It can be compared to the talcum powder. That means the powder which we often apply on our own bodies every day, you know. So it is that fine and smooth. However, there is a very big problem with this regolith whenever our astronauts actually go to space. This regolith, often you will find whenever you watch videos of these astronauts walking, running around on the moon, you will find these regolith which is heavily stuck on the space suit. So thousands of dollars of space suit which is being constantly made dirty by this moon dust. That means the regolith. So why do you think this regolith is actually getting stuck on the astronaut suit? And more importantly, is there any problem? For example, we also wear clothes, we go outside, sometimes we go to very dusty areas and our clothes become dirty. It's fine, they get washed. So what's the problem? Is it just because it's $1,000 suit? So, that is why we are afraid of, damaging it or something like that? Or is there any other reason? So do let me know in the chat that why sticking off this regolith is actually a problem. Okay. So the question that comes up is, why does the dust stick to everything? Why is it basically sticking to everything? So if you just think about the things which are present on the moon, you can think about, well, there is lack of gravity. That might be the reason. Is the spacesuit magnetic? Is the spacesuit just pulling these dust particles towards itself? Does soil have any moisture in it? Is there water present on the moon's surface? Or is there any kind of iron which is present in the soil? And due to that iron, some kind of ionized particles are getting produced and they are then sticking to the spacesuit. Or is there any other weird reason why is that dust sticking to everything? So how about you give me your answer in the chat? Meanwhile, I can see that many of you are actually answering about the questions that I asked earlier. So many of you are actually answering low gravity on the moon as well. Okay. But before coming to that, I had asked you previously one question that what is the nature of that regolith? What is the problem of that regolith sticking to the spacesuit? So this regolith, although it is very fine and smooth, those small dust particles, due to the lack of that gravity, they act as small shards of glass. You have seen shards of glass, very fine particles of glass, although they are very fine, but sometimes if you rub several particles against your skin, maybe in your hands or your feet, then your hand and feet skin will get ruptured. There will be blood oozing out of your skin. So similarly, that is the problem with this regolith. It actually damages the space suit. Okay, it may damage the equipment which are attached to the suit. It may damage the glass of the helmet of that suit. And due to this reason, the sticking of regolith is a big problem. Now, why does the regolith actually stick to everything? Well, to understand why does the regolith stick to everything, you need to understand static electricity. So static electricity is actually the reason why that moon dust is actually attaching to the spacesuit. And in fact, not only the spacesuit, it attaches to any kind of material, be it any other non-living material. Let's say we are sending some kind of lander, some kind of rover, some any other object. These regolith particles simply go and stick and cling to those surfaces. What is the reason? Static electricity. So what is static electricity? To understand that, we have this STEM experiment for you today. Now, for those of you who are already aware, I'm sure you have already arranged the materials, but let me just quickly give you a glimpse of what are the materials that we require in today's experiment. So we require one balloon, and along with that, and if that balloon gets burst, you will have to use another. So use a balloon, inflate it, and tie it up at the end so that it does not just burst out. Then you require a worksheet. Now, for the worksheet, we have provided you a link in the description of YouTube itself. So you can click on the link and you can download that worksheet. And as of now, just to fill in the answers, you can use a rough page or a rough notebook and write the answers. Later, you can get a printout of the worksheet and fill it fairly so that you have it for your later reference. Okay. And you can also find the link to download this worksheet in the live chat for those of you who have joined us live. You also require a woolen cloth, although it is optional. But if you have any kind of woolen cloth, be it monkey cap, be it sweater, gloves, anything, you can use that. Anyway, winter is very close. Winter has almost come in many parts of our country. So some of you might have it. Apart from that, you also need certain other items. For example, you can just gather small pieces of paper, very small, tiny pieces of paper. Then you can take small pieces of aluminum foil. Even if you don't have it, it's fine. But if you have, then try to make very small pieces of aluminum foil, a few rice grains, and few sugar particles as well. That means a few lightweight everyday objects that you can easily find around your house. Once you have these materials ready, we can now proceed with this experiment. Now, to perform this experiment, what you need to do is that you need to inflate the balloon, tie it up so that it's ready. For example, I myself have the balloon with me. Okay. Now, what you need to do, you need to rub the balloon with the woolen cloth or your hair. So if you have the woolen cloth, you can use it, or you can simply use your hair. So here is something which we all have, and you can simply use your hair to rub this balloon. Okay, so you can see that I am basically rubbing this balloon against my hair itself. Okay, it might be a crazy, but I'm rubbing this balloon on my hair itself. So after rubbing, what will happen is that it might develop something within its surface. So what you need to do after rubbing it against the cloth or the or your hair, you need to bring it close to the small paper bits that you have. Okay, so after you bring it close to the small paper bits, you need to note down your observation. So do let me know in the chat that what is it that you observe when you bring that rubbed balloon near the small pieces of paper. Okay, and make sure that you also write down your observation in that rough sheet or in that worksheet in a similar form, in a form of the table that has been formed in that worksheet, so that later you can note it down fairly. So just like this, you can just take the balloon very close to those paper bits. Just make sure you are bringing them very close, just a few millimeters away from it. Okay, and then you can get it close. I'm getting some responses in the chat as well, so I will get back to that. After the paper bits, repeat the same step for the rice grains as well. You have the rice grains, try to repeat the same step for the rice grains. Make sure that you charge the balloon once again before you move to the other kind of object. So let's say you have done the experiment with the paper bits, then move on to the rice grains. Okay. Now, after the rice grains, try it with the small pieces of aluminum foil. After the aluminum foil, you can go for the sugar molecules. Okay, the small sugar particles. You can bring it near to the sugar particles and you can again see what is happening. Make sure you are rubbing it once again with the woolen cloth or the hair after you are switching materials, and make sure that you note down your observation. You can also give me the observation in the chat box as well. I'm already seeing a few people who are responding to me in the chat box. So somebody also says that the paper is charged. So is it the balloon? Hence the balloon attracts the paper. So I'm getting several different kind of responses. We'll come to those eventually. So once you have done that, you have the worksheet. So for you, I have magnified the worksheet for you over here. So what you can do is that as of now, I have performed the experiment as of now. So I have just noted down my observation, but you can again go back after this session. If you're not able to perform it right now due to any reason, due to lack of materials or time, you can just go back after the session and you can perform the experiment slowly and gradually, and you can make sure that you are properly performing it. Once you perform it, you need to note down your observation. So for example, for the small paper pieces, what I have done is that I have made two columns: sticks without rubbing and sticks after rubbing. Okay, so I'm sure that since many of you have already, responded to me in the chat box, I'm sure that all of you are aware that these materials will either stick to the balloon or they won't stick to the balloon because of the static electricity, right? So what I have done, I'm noting down in both cases. What happens? Does that material actually stick without rubbing the balloon? And does that material actually stick after rubbing the balloon? So for the small paper pieces, I found that they are not sticking to the balloon when I'm not rubbing them, simply because the balloon does not have any kind of specific thing on its surface, so it does not stick. So after that, when I rub it, I find that it's sticking to the paper pieces. Similarly, when I do it for the aluminum foil, I find that the small pieces of aluminum foil do not stick without rubbing, but they stick after rubbing. When I perform the same with the sugar, I get similar kind of result. And I get a very similar kind of result when I perform it even with sand. So if you have small sand particles available with you, you can repeat the steps for that as well. When I perform it for rice grains, however, I find that, oh, it actually does not stick. And same goes for the slightly moist paper. So what happened with the rice grains and the moist paper? Do let me know in the chat why the rice grains and the moist paper did not stick to my balloon. Okay. Now, instead of the balloon, if you are not having a balloon, you can also use a plastic scale. I can see that some of you have already told that you are using the plastic scale. So make sure that you are charging the plastic scale in a similar manner, just like you did with the balloon. Okay. Now, the question comes up is what is static electricity? Because now all of you are aware that these materials are sticking to the balloon or the scale because of static electricity. So what exactly is static electricity? Well, it refers to the buildup of electrical charge on an object. So basically, if there is any object, when you are rubbing it up, there is some kind of electrical charge that is getting built on the surface of this balloon. Okay. And when the electrical charge gets formed on the surface of this balloon, it becomes either positively charged or negatively charged, and then it is actually able to attract certain very lightweight materials, such as the paper bits, such as the sand grains and stuff. But what is the reason behind this buildup of charge? Are we providing any electricity, or have I connected the balloon to a battery or something? No, right? Then how is a charge out of nowhere getting generated on the surface of the balloon just by rubbing it against my hair or by just rubbing it against a piece of cloth? So that's the big question. Before we answer that question, I had also asked you before this that what is the reason why the balloon is sticking. So you had already given me, many of you have also given me your responses in the chat box that the moist paper is not able to attract the paper because water is a good conductor of electricity. Well, if water is a good conductor of electricity, it should be able to attract it, right? But that is actually not the reason. Well, the primary reason itself is that these materials are slightly heavy, right? When you make the paper wet, slightly wet, it becomes heavy. Similarly, rice grains are also pretty heavy compared to your scale or the balloon. That is the reason that they are not able to stick. But more importantly, apart from their weight, they are also not sticking because of the fact that their electrons are not able to flow properly. For example, in the moist paper, when you are actually working with the surface, when you are bringing the balloon close, it's due to the attraction and repulsion of particles which are present inside the surface. So to understand that, let's just make a quick recap of something called atom, which I'm sure that almost all of you are aware of. The building blocks of everything, that's what we have always studied in our science textbooks, right? So be it a table, be it hair, be it balloon, be it the scale, be it the rice grains, sand, everything, you can see that all these materials are actually made up of atoms. In fact, the entire universe is made up of atoms. So then what exactly makes these atoms so special that they make up every state of matter, be it solid, liquid, or gas? Well, atoms have this very specific part called the nucleus, first of all. So this is how your atom basically looks like when you look at under a very powerful microscope, right? So it has something at the center with with some particles which are revolving around that center. If you look at the center, you have the nucleus, which is made up of two kinds of particles, protons and neutrons, while you have electrons, which are actually the particles which revolve around these nucleus. So if you look at the proton, it is the positive charge, while neutron doesn't have any charge, so it has zero charge, also called neutral charge. That is why the term neutron. Protons and neutrons together are heavy and form the nucleus of the atom. However, electrons, they keep moving around this nucleus. They are negatively charged and they keep moving. So the main recap in this atom is that it is made up of the nucleus and the electrons. The nucleus in turn is composed of protons and neutrons. The main focus point here is the protons, that is the positively charged particles, while electrons, they are the negatively charged particles. And since in an atom, protons and electrons balance each other, that means number of protons is equal to the number of electrons, these charges actually get balanced. So atoms are overall neutral. That means they do not have any charge. That means they have same number of electrons and protons. Now, why did we discuss this very basic thing, which we might have already learned in our very junior classes for people who are aware of? Well, it's because these are the fundamental particles that is making up our entire universe. So it is important to understand that these fundamental particles themselves are responsible for this entire force called electrostatic force. So you might have heard that like charges repel each other. That means if positive or negative charges come close to each other, they will repel. That means they will in turn move away from each other. While the unlike charges will attract each other. That means positive and negative charge tend to come close to each other. They attract each other. Okay, something in this way. So this is the basis of the electrostatic force which is getting generated between your charged up balloon or the scale and the paper bits or the particles that you're trying to attract. When you're rubbing your balloon or the scale against that cloth or the hair, what is happening is that electrons are getting transferred. So let's zoom in a bit. If you zoom in, then you will be able to see the surface of the balloon and the cloth itself. Both the surfaces are made up of atoms. That means both the surfaces actually contain electrons which are moving around the nucleus. So what is happening is that when you are actually rubbing it off, then these electrons are getting kicked off due to the friction. I'm sure that you are aware of friction, the resisting force that gets generated between two surfaces. So due to this friction, the electrons get kicked off. So let's say that I'm rubbing the balloon against the cloth. So what is happening is that these electrons are actually getting transferred from that piece of cloth into the balloon due to that friction. Now, what is happening is that due to the electrons moving away from the cloth to the balloon is getting overall negative charge because the balloon was initially neutral, remember? But now it is actually getting negatively charged because of the excess of electrons. So what will happen to the cloth then? Well, it will become positively charged. Okay, now since the balloon is now negatively charged without any source of electricity, this entire surface has now become negatively charged. That means it has some kind of charge. Doesn't matter positive or negative, it has some kind of charge. So when you are bringing that balloon close to your paper bit or the small particle, it is due to that repulsion. Now you can see how the electron actually got repelled. Okay, you can see how the electrons from the balloon are repelling the electrons. That means moving away the electrons of that surface. So now you have the positive charges on one side and the negative charges on the other side. So if the electrons move away, there are positive charges left out. The positive charges will get attracted to the negative charges, and eventually the material will get stuck to the balloon. So I hope that you have performed this experiment and you are clear that how this electrical charge is getting developed on the surface due to static electricity. Since this electricity is not moving, like the electricity moves in the wires through the conductors, since it is not moving, it is called static. It is present at that moment. However, this process is actually temporary. Do you think that the paper bit will remain stuck to the balloon or the scale, or will it eventually fall off? Do let me know in the chat, and also do let me know what is the reason behind your observation. Okay, whether it is remaining stuck or whether it is falling down, do let me know what is the reason behind your observation. So now that we have understood what is static electricity, remember we were talking about the moon dust. So what happens on the moon? Well, you might think that where is static electricity coming up on the moon? For billions of years, the moon has been bombarded repeatedly by asteroids, comets, and other space rocks. Because of the lack of atmosphere, all these space rocks reach the surface of the moon at full velocities and they eventually hit the moon's surface. And due to this hitting, these dust particles on the surface of the moon, they undergo friction. And due to this friction, these materials get charged up. So that is one reason how the moon dust is actually developing a charge, a static electricity. However, apart from the static charge that is getting created on the moon dust surface, there is also something called solar radiation. That means solar winds which are coming from the sun. These are not the typical air-like winds which we have on our Earth. Instead, it's the wind power of the solar radiation itself. So you have the sun, which is huge, and due to these solar winds, these are so powerful that they actually cause some charge to develop on the moon's surface. What these solar winds do is that they push off the electrons which are present on the surface of the moon. That means which are present in the moon dust particles. And when they push off the electrons, just like we saw in the example, in the experiment, all these positive charges, they remain at their place. And due to these positive charges, which are remaining at the place, the moon dust particles become charged up. That means they become positively charged. And since they are charged up, they will now try to cling to any kind of surface which it comes in their way, be it the spacesuit, be it any kind of scientific equipment, be it rover, lander, whatever it is. It will eventually try to stick to the surface, whichever it is close to. And this is since it's a continuous process which is occurring on the moon's surface, this entire process actually occurs continuously. And therefore, whenever astronauts go to the surface of the moon, they face this problem of regolith clinging to their space suits. Okay. Now, I have already got a few answers who say that it will actually fall off. So I had asked you that what will happen to the paper bits, what will happen to the materials after some time, after a few seconds. Well, after a few seconds, it will eventually fall off. Why? That's because the charges, remember why it was getting stuck? It was getting stuck because if I again show you that particular animation, you can see that it was getting stuck because the electrons were actually reoriented towards the other side of the surface. However, eventually the electrons will again come back to their natural position. And once again, all the surfaces will become neutral. And once the surfaces become neutral, both the surfaces on the balloon and the paper weights will become neutral, and neutral objects will not attract each other anymore. So since there will be no charge on either the balloon or the paper weight, there will be no more attraction between these two surfaces, and it will eventually fall off. So I'm sure that that makes it clear that why this dust sticks to everything. Now the problem is, we have understood the problem, we have understood the reason behind the problem. So what's the solution? Well, NASA has been constantly working on it. Even multiple space agencies have worked on it, and some viable solutions have come up. But as you know, in space science, nothing is so simple and straightforward. We need to take into consideration a lot of different factors. And considering that, NASA actually came up with a very innovative solution called the electrodynamic dust shield. So this electrodynamic dust shield, in short called EDS, is a very specific kind of material that has been designed by NASA, wherein you can see that if there's dust particle on this surface, it eventually falls off. That means the surface gets rid of these dust particles. Now you might think, how is this actually happening? Is this some kind of magic? So if you are aware, then do let me know in the chat. Otherwise, I will show you another clip which is actually showing you how it actually gets rid of these dust particles. So you can see how it gets rid of these dust particles whenever there is some kind of electricity that is flowing through it. So you can see certain wires and certain electrodes which are attached to this material. So what is happening is that this material actually generates a very strong electric field. So there is very strong electric field that gets generated within this material. Due to that electric field, there is eventually a magnetic field. So as you grow up, you will learn that along with electric field, there is always a magnetic field that gets developed. That magnetic field actually disturbs the entire orientation of that moon dust. So remember, the moon dust was reoriented due to the solar winds, due to the friction of the asteroids, and it was getting stuck to the surface. The electric field will disturb that orientation. As such, the moon dust will not remain charged anymore, and it will fall off and it will actually detach from the surface. So this is how they have designed this electrodynamic dust shield. Apart from this, there are also certain other solutions that have come up. Do let me know in the chat if you're aware of any other solution. For example, there is also another viable solution called the protective Kevlar vests. Okay, these are usually used to make bulletproof vests, although they have been not into commercial production. Electrodynamic dust shield is something that they are constantly working on, and probably they will come into play once we start our following next missions to the moon. So I believe that all of you had fun performing today's experiment. If you have not been able to perform it due to any reason, make sure that you watch the video, you watch the steps properly, and you perform it, because it's a very simple but very exciting experiment, and it will help you to learn a lot about static electricity and why the moon dust also behaves in a similar way. So with that, thank you so much for joining. I recommend all of you to scan these QR codes and join our Spacetopia page, which I had shown to you earlier. So what I'm going to do is that I'm going to quickly give you a revisit to our Spacetopia website, where you can go and you can register yourself. Registration is, of course, free of cost. You can use your email ID to register. Once you have registered, you will land on this homepage, where you will be able to again witness the live sessions that are coming up in this month. So you can see today we already have this STEM challenge, but other than this, next week we'll have a very intuitive and exciting session on this Comet 3I Atlas, and we'll find out if indeed it's a comet or an alien spaceship, as many astronomers and scientists are actually talking about. And we'll clear off all the facts and myths about it. After that, we'll also learn about the Curiosity rover in the following week. And finally, towards the end of the month, we'll have a mega quiz for all of you. So, to ensure that you win the mega quiz, because you will have certificates and you will get exciting prizes as well. So make sure that you attend all these three sessions so that you have the best chance of winning that quiz, because most of the questions in that quiz will be taken up from these sessions and you will be able to ace the quiz if you attend these sessions. So make sure that you are attending so that you are able to participate in the quiz and you are able to win it. And make sure that you remember you have very exciting rewards as well, which is waiting for you. And just before closing up, if you're not aware, we have our flagship National Astronomy Challenge that is also actually already ongoing. So you can participate in this National Astronomy Challenge. You can go to this website called nationalastronomy.org and you can read more about it. It's basically a national level contest where you will get the chance to actually visit, to actually win a sponsored trip to the Udaipur Solar Observatory, which is located in Rajasthan. So it's a feat of astronomy where you will learn a lot of things regarding astronomy, space science, how these telescopes and observatories actually work. Okay. And it will be a completely sponsored trip, but make sure you will need to win it. And the other terms and conditions about this contest are actually mentioned in this website. So do make sure you check it out. And if you have not participated, make sure that you participate through the school. Although you can participate individually, I recommend you participate through the school as you will get added benefits if you do so. So with that, I would like to thank all of you for joining in today's session. And I hope that you have been able to learn with fun with us. So thank you so much. Have a great day and good night. See you all in